Okay, welcome back. We're doing January 2018 paper 2, chemistry. Now, this is probably my fourth take, and I really can't write over these things again, so we're going to just go through it together. So it says, the Neil is provided with two solutions, M and N. Solution M is aqueous hydrochloric acid containing 3.6 grams per dm cube, whereas solution N is an aqueous solution of sodium hydroxide solution, which has been prepared by using a certain mass of sodium hydroxide in 1 dm cube of solution. So the Neil is asked to titrate solution M against 25 centimeters cube of solution N. And what I did, I wrote the little notations up here because M and N you get lost. So in order to determine the concentration of sodium hydroxide, you titrate the solution HCl against 25 ml of it. So in figure 1, we have some burettes, and they're just testing to see if you know how to read from a burette. And when you read going down, it's getting larger, the number gets larger going down. So here we always read on the meniscus when we're taking readings from a burette. And what I did, I drew the lines to see where the meniscus meets. This is the meniscus here, the curved bottom. Now for 1, 2, 3, 4, 5 of them, you have precise readings, they're right on the line. However, for the first one, it's not on the line, it's in between. But for me, it's closer to 0.3 than 0.2. So I put 0.3 in here, right in here. 0.3. And then I just went ahead and did all the rest, right? Now, how did I know that this was 0.3? What I do, what you would do is minus the little number from the big number. Count the amount of spaces in here. I got 10. And you divide it by the spaces. 1 divided by 10 gives you 0.1. So each of these spaces is 0.1. So you have 0.1, 0.2, 0.3. And as you can see, it's close to 0.3. The next reading would be 25.7. This is 25.5, 6, 7. So you put it right here. The next reading would be 13.3, as you can see here, 1, 2, 3. And the next one would be 38.3, 1, 2, 3. So you're getting 38, 38.1, 2, 3. It's right there. So here we have it. And likewise here and here, you get 40.5 for final and 15.5 for initial. To solve this part now, you just multiply the initial volume from the final volume, where you get 25.4, 25, and 25. The next question asks you to calculate the average volume of solution M. When you look at this question, it gave you this question right here. It gives you the volume of solution M used. So all of this. So what you would do is find the average. You add them up and find the average, as can be seen here. This is what we did. Found the average, add up all three, then divide by 3, and we got 25.1. Now after that, you use whatever information they give you to solve the rest questions. So here now it says, calculate the concentration of hydrochloric acid in solution M in mole per dm cube. All you had to do was look back. If you look back, you will see they gave us the concentration of hydrochloric acid, but they gave us the mass concentration. So they want us to calculate the molar concentration. It's not that hard. And you could use this number of moles equal to mass over molecular mass. You could use that. Or you could simply use some common sense where you could do the calculations. And here you have if 1 mole of HCl has a mass that's given here, right? So we found the molecular mass of H and Cl. Add it together, you get 36.5. If X moles of HCl has a mass of this, which is what we were using in the experiment, then 1 mole will have a mass of this, which is what we calculated here. So we just divide the 3.6 by the 36.5, and we do a cross multiplication. We transpose to get our X. So since this is 1, we just have the same numbers here. And then we end up getting 0.097, two significant figures. And then we get the units moles per dm cube, which no, we are right. So when you divide units, here we have grams per dm cube by another fraction of units. You will just flip it, as can be seen here, right? Once you flip it, you get the units. You take this number and you use it to solve this. It says calculate the number of moles of hydrochloric acid used in the titration. And so we could use this equation here, concentration times volume, where you have moles per dm cube times dm cube, so that dm cubes cancel out. And we take this answer here, and we take the answer from up here, and we put it here. But before we put it here, we convert it to dm cube by dividing by 1,000. Once that is done, we multiply these two, and we get 0.002. Then the next question says, write a balanced equation for the reaction between the hydrochloric acid and the sodium hydroxide solutions. And we have HCl, aqueous plus NaOH. These are the molecular formulas, but formula units. And then we have, whenever you have an acid and a base, a salt and water is formed. And this is known as a neutralization reaction, because water is formed. Okay? Then it says determine the number of moles of sodium hydroxide in the 25 centimeter cube of solution used. So if you know how to do a titration, you have the burette, then you have the conical flask, and then you have something like a white tile underneath here just to give you some color, distinct color changes. Once the indicator is in here. And we know that we use 25 ml of NaOH. And of that 25 ml, from the equation, from the balance equation over here, we know that it's a 1-to-1 ratio. Theoretically, 1 mole of HCl would react with 1 mole of NaOH. So if you write it back over here, we have HCl to NaOH. You see theoretically, 1 mole of acid will react with 1 mole of base. So then, if 0.02 moles of acid were in the burette, and that's what was reacting with the base to neutralize the base, if this amount of moles were used to neutralize this amount of base, then if it's a 1-to-1 ratio, it will be the same number. So it will be 0.002 moles of NaOH based on the theoretical yield. So then they went on to say calculate the concentration of sodium hydroxide in grams per dm cube. So they want us to convert from molar concentration to mass concentration. They gave us the molar mass of sodium hydroxide. So we then equate it and say if 1 mole of sodium hydroxide has a mass of 40 grams per mole, then 0.002 moles of NaOH is equal to X. You cross multiply, and you would see that 0.002 moles of NaOH has a mass of 0.08. You take that mass, you divide it by the volume of NaOH that we have. But first you convert it to the decimeters cube, and we get 3.2 grams per dm cube. All right? So remember the units of molar concentration are moles per dm cube, and the units of mass concentration is grams per dm cube. Okay? Right after that, there was another question for number 1. And in it, it says, the student went on to further conduct an experiment to determine the effect of temperature on stearic acid. Stearic acid is an organic acid that exists as a molecular solid with a melting point less than 100 degrees Celsius. Okay, so we have here table 2 shows the data she collected, and we have all of this. This is table 2. So it says identify the forces that exist in a molecular solid, the intermolecular forces. Don't mix up the forces with the word bond. Then, the bonds are covalent bonds. They're strong between the atoms, but the molecular forces, the intermolecular forces, are very weak between the molecules. Now, sodium chloride is another solid, but it has a higher melting and boiling point than stearic acid. Explain why is this? Now, sodium chloride is an ionic formula unit. The structure is held together by strong electrostatic forces between the positive and negative ions, whereas in stearic acid, the attraction between the molecules are weak. Hence, sodium chloride would have higher melting and boiling points than stearic acid. Now it says, using the axis provided on figure 2, page 9, plot a graph of temperature against time from the information in table 2. One point has already been plotted. Draw the best fit curve through your points. So, using this table, we'll plot the points, and to figure out they were gracious enough to plot 1, and they were gracious enough to give us the axes right here. So, if you ever want to figure out the points between the numbers given, you always minus the little number from the big number, as can be seen here. 10 minus 0 gives you 10, and divide it by the spaces. So 5 and 5, that's 10 spaces between here and here. And we get 1. So each point is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then if you want to figure out the point system between here, you do the same thing. 1 minus 0, divide by the amount of spaces, you get 0.1. So this will be 0.5 right here. And then we start to plot. When it's 0, when the time is 0, the temperature is 19. So we have it here, temperature 19. When the time is 1.5, the temperature is 40. When the time is 2 minutes, the temperature is 48. Right, so this is 49, 48. When it's 2.5, the temperature is 53. 1, 2, 3. When it's 3, it's 55. When it's 5, it's 55. So we are complete with all of this because 7 is plotted for us. And since it's an X, we might as well use X's. Let's match theirs. I usually like points, but okay, X and X. So you find your best fit line, your best fit curve through here. It might not hit all of them, and then it goes straight across here. Right? So obviously the melting point of this will be 55 because the plateau is right here. But they didn't ask that. Alright, so this is the end of question 1. I hope this helped. See you around for question 2.